We're going to look at lesson 1-1 on signed numbers. And basically, we're going to talk about different types of numbers. And this is a pretty quick and hopefully easy lesson, which is basically add, subtract, divide, multiply, and work with fractions and decimals. So numbers obviously are the core part of mathematics. And as you can see, I'm starting in lesson 1-1 from the 104 text. So let me start in. So numbers are the core parts of mathematics, but we're going to talk about, in this case, the types of numbers and their uses. So we're going to categorize some numbers. We're not going to focus too much on that, but I just want to talk about that so that later on in the semester, when I talk about different numbers, we'll know what those mean. And then look at some properties, obviously, of numbers. So the most basic types of numbers that we're going to use are counting numbers. Numbers like 1, 2, 3, 4, 5, 6, blah, 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 blah. And when we go through, I'm going to skip down here. If I ever say the word integers, I mean the counting numbers plus 0 and plus negatives as well. Okay, integers is negatives, 0, 1, 2, 3, 4, but whole numbers, I don't have any decimal parts. And then we can also talk about quantities that fall between two counting numbers, like fractions. Fractions like 1/2, 5/8, 13/3. 13/3 is an improper fraction because the top of the fraction is bigger than the bottom. We call that an improper fraction whenever the numerator, that's the top part, is bigger than the denominator, that's the bottom part. So 1/2 and 5/8 are proper fractions. And I mention that because on some things, I'm going to ask you to put your answer as a fraction. And what I'll be looking for is an improper fraction or a proper fraction. Okay, so there you go. Those fractions can be converted into decimals. And then there are also other numbers like square root of 2. Square root of 2 cannot be converted into a fraction. And when things cannot be converted into a fraction, they're called irrational numbers. So rational are things that can be converted into either a proper or an improper fraction. 0 is obviously there, all that kind of good stuff. The other thing that we're going to talk about extensively is opposites and negatives. So every number that you know has an opposite, although 0 is the exception to that rule. 0, you can think of itself as the opposite of itself. Some people think of it that way. But opposites are just negative signs. So opposites, we're going to use negative signs to denote that. So -2 is the opposite of 2, all that kind of good stuff. All right. I'm going to skip the sign numbers part because I think we can do that. And I just want to talk about how adding and subtracting works. And the really interesting thing about adding and subtracting numbers is what happens with something like 40 minus -15. So what happens when we subtract a negative? When we subtract a negative, basically what we're doing is we're doing the opposite of a negative. The opposite of a negative is a positive. And so subtracting a negative is just like adding a positive. Okay, so 40 minus -15 is the same thing as 40 plus 15, which is 55. Okay, so the opposite of an opposite is a positive, or the opposite of a negative is a positive. All right, And that kind of just leads us to the cooperative group problems. Now, this is these are, I should say, some cooperative group problems on adding, subtracting, dealing with positives, negatives, all that kind of good stuff. I want you to push pause on the video and try these cooperative group problems that are right here, 1 through 10, should be pretty quickly able to do that. That's on page 7 of the workbook. So push pause, and I'll give you about 5 seconds to do that, and then I'll come back. All right, so here's what I've done. I've created a Word document with those same problems. 72 plus 15 is equal to, whoops, I 87. Typed in a weird thing there, sorry. 72 minus 15, 72 minus 15 is equal to 57, so equal to 57. 72 plus a negative 15, so we're adding a negative. That's the same thing as subtracting. Adding a negative is the same thing as subtracting for the exact same reason we talked about earlier about subtracting a negative. So 72 plus negative 15 is once again 57. And then 72 minus a negative 15 is equal to 87. Now what you can do all of these types of things on your calculator, all right? I obviously have the TI-30X2S. So if you wanted to do all of that, all these buttons there. One thing I want to point out though on your calculator is the difference between the minus button and the negative button. All right, so here obviously I'm using the TI-30X2S calculator there. When you're typing things into your calculator, this is just a picture of it by the way. When you're typing things into your calculator, let's say you wanted to do 72 minus a negative 15, you'd hit the 7, then the 2, and then this blue button over here on my calculator, it's blue, is the minus. So you do minus, and then you might hit a parentheses right here. And then the negative sign is right here. So don't hit minus again. If you hit 72 minus and then another minus 15, it's going to give you an error. So you have to hit 72 minus and then in parentheses, and then this is the negative 15. And then you can end your parentheses just like that. So the minus button over here in my calculator is blue, and the negative button, or some people call this the opposite button, is down here. So that's all I wanted to point out, the difference between the minus and the negative on your calculator if you are using your calculator. So we're going to take 42 minus 67 for the next problem. That's a negative 25. By the way, when you're typing things in a computer, the negative and the minus button are the same. 42 minus negative 67, that's 109. 13 minus 21, that's a negative 8. 17 plus negative 32, that's a negative 15. 89 plus 45 is a 134. And 14 minus negative 6 is a 20. So that's hopefully what you got on those cooperative group problems. Now, the other part of 1.1, there's really two other parts. Whoops. The other part of section 1.1, I should say the next part, is multiplication and division. And hopefully we're going to focus on different division, signs, and all that kind of stuff, notation. One of the things people sometimes get confused on is the difference between multiplication sign, like this cross here, versus the dot, versus parentheses. All three of these mean the same thing. All three of these mean 2 times 3. They're just written in different ways. Now, why we would have different notations for multiplication? Well, one of the reasons we have is because this multiplication cross sign looks like an X. And so X is a really common variable that we use in algebra. And so we don't like to use that as much. So a lot of times you'll see the dot or the parentheses when you're dealing with algebraic stuff. All right, you can read that kind of stuff. The other thing that we'll see is two division signs. Obviously, the division sign that looks like a minus sign with a dot above and below versus this, which is a fraction. It means the same thing, right? 6 divided by 3, 6 over 3, it means 6 divided by 3. In fact, if you type it in on your calculator, 6, and then hit the divide sign and 3, the actual divide button on your calculator, oops, you can't see it in this picture, but the divide button looks like the line with a dot and a dot over it, over and under. If you hit that, you're going to get a slash. All right, that looks more like a fraction on your screen. Now, so that's the different notations. The only other thing that we really need to understand is about multiplying numbers. Positive times a positive gives us another positive number. Positive times a negative is going to give us a negative number. A negative times a positive gives us a negative number. And a negative times a negative is a positive. By the way, this negative, negative, multiplying each, it probably makes the most sense when we think of directions. Let me push pause here and pull that up. Let me give you an idea here based on a really uh, weirdly drawn number line here. I usually draw this on the board when I'm in class, but I don't have that access here. So if you think about any number whatsoever can be drawn on a number line. And so let's say this over here is the number 2. Now, what that meant is that we went to the right 2 units, okay? Well, what would it mean to go a negative 2? Well, a negative 2 would have went to the left the same amount. So I do this. There we go. Getting there. So negative 2 would have went to the left 2 units, left of 0. And if you think about negatives like this, what negatives do on a number line is they change directions. So when we talked about subtracting a negative, that was basically doing a direction change and then another direction change. So subtracting a negative 2 would have been the same thing as adding 2. That's the same thing as multiplication by a negative. If I multiply a negative times a negative, what I've done is essentially done 2 direction changes. The first negative switches my sign so that I'm going left. When I multiply another by another negative, it switches the sign back, so I'm going right again. So if you think about multiplying a negative times a negative, it's really a positive because we're doing 2 direction changes on the number line. So that's what's going on there. And obviously, if you think about positive times negative or negative times positive, that's just one switch of directions. So you're going left on the number line, which is the negative direction on the number line. Now the same thing is true for division as well. Dividing by, negatives or positives work in the exact same way. So what I'd like you to do is push pause on the video and try all of the problems here from 1 through 8, and then go on to the next page and try all of the problems on the cooperative group stuff from problems 9 through 15. So that's on pages 9 and 10. So go ahead and push pause on that. Try problems on pages 9 and 10 of the workbook, and then I will come back and do the problems on a Word document. All right, so hopefully you got those on your own and didn't have any issues there. So let me pull up mine. So 4 times 7, number 1, 2, and 3 are all the exact same problems, which is different notation. Obviously, 4 times 7 is 28, no matter which notation you use. 4 times negative 7, well, positive times negative is a negative, so it's just negative 28. Negative 4 times a positive 7, also negative 28. When you get down to 6, we got negative times negative, so you get a positive 28. And then obviously 6 times 8, we're gonna utilize different versions of that. So positive times negative gives me a negative, and that 6 times 8 is 48, obviously. So 6 times 8, those are both positive, so we're gonna get positive 48. Negative 6, negative times positive is a negative 48. Negative times negative is once again a positive, so 48. So positive times positive and negative times negative yield positives. When you have one negative and one positive, you get a negative. 11 through 15 are different versions of 35 divided by 7. When you have positive and negative numbers. 11, obviously, 35 divide 7 is 5. 35 divides 7, that's just the exact same thing, but with different notation. So that's 5 as well. Negative divided by a positive is a negative, so we're going to get a negative 5. This is positive over negative, so once again, we get a negative 5. And then on problem number 15, we have a negative divided by a negative, so we get a positive 5. Sorry. There we go. So those are all the cooperative group problems. Again, I went over those really quick because I expect that you would have done those. Now the last part of section 1.1 is how to deal with fractions. And this is of particular interest when we're moving on later on. We're going to solve equations with fractions and decimals and all that kind of good stuff. So we need to know how to type fractions into our calculator and how to use our calculator to deal with add, subtract, multiply, divide fractions. Now, one thing that's kind of interesting is this is saying positive over positive is the same thing as negative over negative. Negative over positive and positive over negative is the same thing as the opposite of the fraction itself. So kind of a thing we're going to utilize later on, and mostly in section 2, not 1, 2, but I mean in section 2 of the book. So here's the deal. Let me kind of talk through dealing with multiplying and dividing utilizing fractions and decimals with your calculator. All right. So this first problem says 1/2 multiplied times negative 3/4. So we're multiplying a fraction here. And essentially what's going to happen is that I'm going to type that into my calculator. I'll show you how to do that in just a moment. So here we go. Let me focus on this. 1/2 times -3/4. Now, I want you to focus on that this problem started dealing with fractions. And so the key thing here is we want our answer, since we started with fractions, we probably want our answer to end with a fraction. That's different from number 2. Notice that number 2, we're starting with decimals, 7.2 divided by -6. So we'll probably end with decimals on number 2. So here's the deal. So let's do 1/2 multiplied times -3/4. So there's our calculator. Type in 1 and then obviously the divide button, divide 2, and then use the parentheses, negative. Remember the negative is the lower key there, lower white key. And then 3 divided by 4, and then end the parentheses. So your screen should look something like this. 1/2, and then in parentheses, -3/4. If you have a bigger sign, then you hit the minus sign, which is incorrect. Now, once you hit enter, again, that's on the lower right-hand part of your calculator, you're going to get this. And mine has some, it's hard to read there because I'm using the camera, but it looks like -0.375. And that's okay, but it's not great. This is the decimal version of the answer to this problem. But remember, this problem started in fractions, so we want to get out a fraction. Now we can easily make our calculator give us a fraction. What you'll do in order to give a fraction is you'll just hit the second key right here, and then you'll see this F and then left arrow, right arrow, D. That FD switches back and forth between fraction and decimal. So you hit second, and then this button right here, which is the fraction to decimal switch. Now, if you hit PRB without hitting the second first, you get a whole different menu. So make sure you hit the second first, and then FD switches back and forth between fractions and decimals. And so you'll get to this screen, then you'll just hit that second FD, and your screen will look like this. It'll say take that answer, which was negative 0.375, switch it between a fraction and a decimal, and you get -3/8. So that is the fraction form of the answer. All right. So if you were writing this down and it said put your answer as a fraction or a proper fraction or an improper fraction, you would write -3/8 as the answer. Now, by the way, if you hit answer FD one more time, it will change back to a decimal. So it'll change it back to the -0.375. So if you want to go back and forth between a decimal and fractions, it is that key that I showed you, the F to D. So what I would like you to do for the remainder of this is try to utilize that key to switch back and forth between, uh, let me, let me say it this way. Let me start over here. Use your calculator to either multiply or divide. If the problem starts out using fractions, try to give your answer as a fraction. If the problem starts out using decimals, give your answer as a decimal. So go ahead and try that, those cooperative group problems, numbers 1 through 5 on page 11, and then numbers 6 through, I don't know when this stops, I think 10, yep, 10 on page 12. So go ahead and push pause on the video and do those. go through these, and I'll do these fairly quickly, but I will highlight some of the features of the calculator. So we already saw that if we take 1/2 times -3/4, we get -3/8. By the way, when you do this fraction to decimal stuff on your calculator, it is going to automatically reduce to the lowest form of the fraction that you want. So 3/8 is already reduced to the lowest form. Now, when you type in 7.2 divided by -6 for problem 2, you get a -1.2. You would keep that because you started with decimals, so it's probably okay to end with decimals. Again, check when you're doing the homework if it says leave your answers as fractions, improper fractions, or if it says leave your answer as a decimal. Now, when you type things in your calculator, on problems like number 3, it is very important that you put parentheses around those fractions. If you do not put parentheses around those fractions, then the orders of operations are going to be all thrown off. So when I did this, -1/2 divided by -3/4, I end up with 0.666666, lots of sixes, and then a 7 at the end. That's our calculator's way of basically the calculator rounds it to a few decimals. So since this is a decimal and we started with fractions, I would rather convert that to fractions. So I'm going to hit that second FD button again. And when you do that, you end up with a fraction of 2/3. Okay, so that fraction to decimal button comes to play here again. For number 4, -5 times -16.8 gives me an 84. That's nice. There's not any fraction answers or decimal answers to deal with. Number 5 is -3 times 14, and negative times positive. No fractions even to deal with, or decimals. That's kind of nice. Whoops. Hit the wrong button, I apologize, is equal to 84. Oh, I'm sorry, did I say 84? I typed that in wrong. -42. I hit a wrong button there, which happens to the best of us. So number 6, -12.68 divided by -5.2. Ooh, this one's an ugly, ugly, ugly looking decimal. It's about 2.43. 2.43. 846. Oh, you know what? I screwed that up. I hit another wrong button. I apologize. 12.48 divided by -5.2. Oh, that's just 2.4, isn't it? Shoot. I apologize. Once again, I'm getting thrown off. I'm hitting wrong buttons. So I got 2.4. And since this started as a decimal and this one started as a decimal, I'll leave this as a decimal. If on the test or something it said write your answer as a fraction, then I'd go to that FD button. All right, let's see if I can type one in right. So -2/3 times 5/8, -8. -2/3 times 5/8 gives me an ugly looking decimal. Now, this is a nice place because this, again, lets us highlight the idea of that fraction to decimal button. So let me show you this on my calculator one more time. So here we go. So I typed in -2/3 in parentheses and times 5 divided by -8 in parentheses. I got this 0.41, lots of sixes, and then a 7. Now, again, where that fraction to decimal button is right here. So second, and then that button. When you do that, answer FD, press enter, you get 5/12. So that decimal right here is the decimal version of the fraction 5/12. So what I would do is I'd go over here and I'd say, well, the question started out with fractions. I'll probably end with fractions. I'll put 5/12. On both the homework and the test, it'll tell you whether to put your answer as a fraction or as a decimal when you get to those places. Now, 8's a little bit unique. 5 times 4/15. If you multiply this, you get 1.3, blah, 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 blah. So you end up with 5 times 4/15, 1.3, lots and lots and lots and lots of threes. Okay? Now here's the issue with that answer. This is the first time we've gotten a number that has a decimal form, which is over 1, and that I need to convert to a fraction. Hopefully you understand what that means. So in other words, if I go back to my last answer of 5/12 was the final answer that I had to put in fraction form, and that fraction was a proper fraction. So the numerator was smaller than the denominator. Here, what's going to happen is 1.333333. When I try to do my fraction decimal, so it's second in that F to B button, I'm going to get 1 and then a little sort of U shape and then 1/3. What that is the mixed number answer to this problem. So let me write that down, mixed number, which is a perfectly fine answer most of the time. Most of the time, the mixed number answer is perfectly fine to write down. However, Moodle doesn't recognize mixed numbers very well. It recognizes improper fractions better. And so what we're going to do is we're going to go to our calculator and tell it to give me an improper fraction. So that's just simple, a button click away. The mixed number to improper fraction, that's the ABC arrow arrow D over E button right here. So you're going to hit second and then that ABC arrow arrow DE, so the ABC button. So second and then this button here. And then you can just simply hit enter. Your calculator screen should look like this. Answer A, B, C to D, E, and it'll give you the improper fraction of 4/3. And most of the time, that's the version of the answer that Moodle is going to, whoops, want from you. So that improper fraction, 4/3 is the one. Again, just to say, second and FD changes from decimal to fraction, and then fraction to decimal goes back and forth. If you hit second, ABC, DE, that changes it back and forth between the mixed number and the improper fraction. Hopefully we all know that mixed number simply means I have a whole number part plus a proper fraction on it. Improper fraction is numerator bigger than the denominator. So there you go. By the way, if a question on Moodle asks for an improper fraction and you get a 5/12, just write down the 5/12. Just write down the write down the proper fraction if you get one. Usually the phrasing will say write it as an improper fraction if needed. All right, took a long time explaining that, but it is important. Let's look at number 9 here. Negative 51.77 divided by 6.2 gives me a negative 8.35. And since this started as a decimal, I'll leave my answer as a decimal. Again, check Moodle for what types of answers you should give. Negative 25 times a positive 17, that's going to be a negative number, so negative 425. And that's all of the cooperative group problems. As you can see, all we're doing here is basic arithmetic, but I want you to get comfortable using your calculator and being able to, change back and forth between fractions and decimals, change back and forth between mixed numbers and improper fractions. When you're dealing with fractions, the calculator is going to automatically reduce it to the lowest thing, so we should be all right. Now, the only other thing I wanted to mention in section 1.1 was that at the end of every lesson, there are two sections. There's an at-home practice and there's a graded homework. You can see the at-home practice is fairly large. It's got a lot of questions in it. It goes through all of the different questions that we went over in that lesson. That at-home practice is a really, really good study guide for the test. In fact, you won't have a practice test because those at-home practice problems, if you took them all out, would constitute a practice test. So the practice test is the at-home practice problems. And at the very end of this book, there's answers to all of the at-home practice problems. I'll scroll down there in just a minute. Now, the other section that every lesson will end with is graded homework. Normally in an in-seat class, I would have you tear out these pages and turn them in. But because we're online, what I've done is created a Moodle online. And 1.1 graded homework is due at the end of the first week. And it'll be these exact same problems for 1.1, just in a Moodle quiz format. So if you click on, portal, go to Moodle, JD Webster, that's me. Got to type in my password, apparently, because it logged me out. Hopefully this won't take too long. There we go. So click on that. This 1.1 graded homework is the exact same thing, as you can see. Preview. 26 plus negative 45. I write my answer in here. And that's the exact same thing as what was 26 plus negative 45, that problem on the graded homework. So the first problem is first problem. All right. I do want to I'll scroll down to the very, 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 very last pages of the book. Very last pages of the book are the appendix. And you see that the at-home practice answers are in there. So the at-home practice problems, you have all of the answers in the back of the book. That's for every section that we're going to go over, not just 1.1, obviously. Now there is another, let me see if we have another. Yeah, so all of these at-home practice problems in the appendix at the back of the book. So hopefully all that makes sense. This is the end of video 1.1, and I will, you should continue on, move on to video 1.2 once it's up and ready.